Hey, Honors Algebra 2. I am not here today, so I decided that I was going to try something different and to record a lesson like I was there with you today. So we're going to try this out and see how it works. Hopefully, you guys will be able to follow along. Hopefully, this will work well so we don't get behind in our lessons. But if for some reason it doesn't, I will answer all and any questions that you have when I come back Tuesday. So I sent you guys these notes over the weekend. So if you can go ahead and pull them up on your Google Classroom or the Google site, let's go ahead and get those pulled up on your iPads so you can follow along with me as I work through these notes today. Your homework tonight will be the end of this worksheet. There should be 2 pages on your screen, and the first page we're going to work through together, and then the second one is going to be for homework for you to do, to practice. So today we're going to be talking about factoring cubic expressions. A cubic expression is something raised to the third power. We've already talked about that before. So before we get started, let's talk about what perfect cubes are. So over here, I'm going to expand this note page so I can write over here. So let's talk about perfect cubes. So if I say 1 to the third power, you would probably tell me it's 1 times 1 times 1, which is 1. Or what about 2 to the third? You would say 2 times 2 times 2, which is 8. Well, let's do 3 to the third. 3 times 3 is 9, times another 3 gives us 27. Let's do several more. 4 to the third would be 4 times 4 times 4, which is going to give us 64. Let's do 5 cubed. That's going to give us 125. And you can always do these on your calculator too if you don't want to do the math in your head. But it's a good idea to start kind of recognizing these perfect cubes. Then we get 6 to the third, which 6 times 6, 36. Another 6 is 216. Let's do one more. 7 to the third. 7 times 7 is 49, times another 7 is 343. Okay, so now we've talked about what a perfect cube is. Let's talk about how we would factor one. So let's start off with this problem right here. X to the third plus 64. What's really cool about factoring cubic expressions is that in the end, you're going to get a binomial, which is 2 terms, times a trinomial, which is 3 terms. It's very cool, but we've got to do a couple of steps, and it might take a while to do this first one because I'm introducing it to you, but after a while, you're going to get really fast at this. So it might look kind of intimidating at first, but I promise it's going to work out, and you're going to, after a couple examples, it's going to click. So the first step that we need to do is see if there's a GCF. In our problem right here, there is no factor that we can take out of both of these terms. So we're just going to write down 3 or x cubed plus 64. So then our second step says to rewrite the original problem as a difference or sum, it should say, of 2 perfect cubes. So what that means is we want to try to rewrite this in maybe a perfect cube. Well, when we're dealing with exponents and variables, this one is just going to can be rewritten as x to the third. There's not much you can do with that one. But you can do something with 64. So come look over at our perfect cube. Do you see which one is a 64? Right here, right? At 4 to the third is 64. So we could rewrite 64 as 4 cubed. And let's put that in parentheses. I don't know why this is scooting back and forth, so I'm sorry about that. So that was your second step. The third step is kind of what we call write what you see, is because you're really taking the cube root of each term in this first binomial or your only binomial that you have here. So we're essentially, I'm going to kind of do this screen so that I can see it a little bit more clearly. So I'm sorry if this is confusing. So what's happening is it's zooming in on this part right here so that I can write a little bit more clearly. So what we're going to end up doing is take the cube root of each of these, because we've talked about this in class. What does taking a cube root if something is already raised to the third power? Well, it ends up canceling them out. So then once we take the square root, we can write, okay, well, the cube root of x to the third is x, and the cube root of 4 to the third is just 4. So that's what it means when you write what you see. So it's really x and 4 that we take here. So we do take the sign with it, and we'll see why later on, but you can go ahead and take the sign with it. The next step might seem a little confusing, but we're going to have this acronym called SMS. We're going to square, multiply, and square. So the first thing that we need to do is we're going to square the first term. So we're going to square that first term, and that first term is going to be x squared. Does everybody see that? You're going to square your first term. That's your first s. And then we're going to multiply. So we're going to multiply the two terms together. So those two terms are x times 4. So that's what we're going to do. So x times 4 becomes 4x. Then we're going to square the second term. So we get 4 squared. And now we're going to, let's see what our third term says. Now we're just going to write it out. So I want to write this out. My first binomial, which we already said was x plus 4. So now I'm just rewriting these terms right here. I have x squared, I have 4x, and now I have 16. Okay, does everybody see that a little bit? And again, we're going to go over a couple of these, so hopefully this will clear up any confusions once we go over a couple. So to rephrase what I just said, first term, we're going to square it. Multiply, we're going to multiply the two terms together, so 4 times x gives us 4x, and then we're going to square our second term. So 4 squared is 16. So here's where it comes in another acronym to help us know what signs we're going to have, because right now we only know the sign of our first binomial, and we don't know about the trinomial. So at this point, we don't have any signs for that trinomial. So we're going to do something called SOAP. So the first S goes with the first sign. And then we have O goes with the second. And then we have AP, like your AP courses go at the end. So this stands for same. So we're going to take the same term. So we did take the same term, didn't we? Our original problem was x cubed plus 64. So we're going to take that plus sign. And then we're going to say opposite. Well, what's the opposite here? Well, opposite of a positive is a negative. So we're going to have a negative sign. And this AP stands for always positive. So no matter what, this last sign is going to be positive. So that is how we factor our trinomial, our cubic. So we have x plus 4, and then we have x squared minus 4x plus 16. Notice we have a binomial times a trinomial. And that's what we're going to get at the end. Okay, so let's do a couple of more together. So at the bottom here, the sums of cubes and a difference of cubes. Right down here, this section, let me change colors real quick. This section right here, this is just showing you the general formula for this, general standard form. So notice that you take a to the third, and it becomes a on your first binomial, and then b cubed becomes b, and then you do S, M, S. Square, you square the first term, and then you multiply these two together to give you AB, and then you're going to square the second term. And then you follow SOAP, same, opposite, always positive. And then we could do the same thing for difference. So let's look at our x cubed minus 8. So I would recommend just starting out with a binomial, so 2 terms, times 3 terms. So that kind of sets you up for your binomial times your trinomial. So off to the side, think to yourself, how can I maybe rewrite x to the third and 8? So we could just write x to the third, and then we could write 8 as 2 to the third. So now we need to, like we did in the first example, cube root each term. So we get x and we get 2. So, and remember, that first sign is always going to be the same as the binomial that you started with. So we can go ahead and put that negative there. And then we need to do S, M, S. So we need to square the first term. So square the first term, you get x squared. Now we need to multiply the two together. We're only looking at the sign. So maybe it would be best, I just erased, that is a big eraser. Okay, let me redo that. Let me get a smaller eraser. Maybe it's a good idea to not put the sign in there, because then that might confuse us on, is it going to be a -2 or not? Well, right now we don't know that because we haven't done our SOAP. So let's just pretend that that negative's not there, and we multiply by x times 2, which gives us 2x. And then we square the second term, and the second term is 2. So we do 2 squared, and that gives us 4. Now we can do our signs, and we can do SOAP. So we get the same sign. We've already talked about that. But the second one becomes the opposite. Well, what's the opposite of a negative? A positive. And then the third term is always positive. And then we are done. And that's how you factor a difference of 2 cubes. So let's go to number 2. Remember, we're always looking for our GCF too. So do we need to take out a GCF here? I don't believe that there is one. So let's go and set up our binomial times our trinomial. Binomial, 2 terms, trinomial, 3 terms. So now think to yourself, or go back and look and see, what did we say? Oh, sorry. Got to get rid of that. No phone calls right now. Okay, so 216, the cube root of 216 is 6 cubed. We can rewrite that like that. And don't forget about your x. So we got to get x cubed. And then we have plus 1 cubed, because 1 times 1 times 1 is 1. So cube root all of those. So if we cube root this whole thing and we cube root the 1, these all get canceled. So we have 6x, and then we have 1. I hope everybody's on board with me. Now we do S, M, S. So we square the first one. So 6x squared is going to give us 36x squared. 6 squared times x squared is going to give us 36x squared. Now we need to multiply the 2 terms in the middle. 6x times 1 is going to give us 6x. Then we need to square the second term. So 1 squared is 1. So SOAP, we do same, which is positive, opposite, which is going to give us negative, always positive. And then there is our factor. So let's go do number 3. 2 more problems I'm going to do with you, and then I'm going to set you free to do your own. work on the rest on your own. Is there a GCF in here? I do not believe so. So we are going to binomial times our trinomial. So 27 can be rewritten as 3 cubed and then x cubed. And then 125 could be rewritten as 5 cubed. So then if we cube root and we cube root, we get 3x 5. And again, we're going to do SMS. So we're going to square 3 squared times x squared is 9x squared. Then we're going to multiply. 3x times 5 is going to give us 15x. And then we're going to square our second term. 5 squared, 25. And now we're going to SOAP. Same. Same is going to be negative. Opposite would be positive. And then always positive. So here's our answer. Last example. So this one, we've got to be real careful here. Can anybody see what happens? We need to take out a GCF. So what is a factor of 24 and 81 that we can take out of here? Well, I hope you said 3. So 24, if we take out 3 out of 24, we get 8x cubed minus, and if we take out 3 out of 81, we get 27. So now, don't forget to bring the 3 down with you. So when you set up your binomial times your trinomial, you don't leave out that factor, that GCF that you took out. So we can rewrite, let's do this again, rewrite 8 as 2 cubed, x cubed, minus 27 we could rewrite as 3 cubed. So then we cube root both terms. And we get 2x and 3. Same thing again, we're going to SMS. So we're going to square the first term. So we get 4x squared. We're going to multiply the second, multiply the two terms together, and we're going to get 6x. And then we're going to square the second term, and we're going to get 9. And now we SOAP. Same, opposite, always positive. So I hope this worked out well for us today. I hope that you understand how to factor cubic expressions. Again, if you don't, then and you still have questions for me, we can go over all of these on Tuesday when I get back. But right now, I would like for you guys to look at the back of this worksheet, and I want you to do all of these today. Okay, you can work in your groups, in your tables together, and hopefully work quietly so that everybody around you can concentrate and think. But I would love for you guys to look at this and try to figure it out, and I will see you on Tuesday. Bye, guys.